Hello everyone, welcome back to Flying Through the Helicopter Flying Handbook. In this video, we're going to finish out Chapter 9 by talking about traffic patterns. So what's a traffic pattern? Traffic pattern is a standard way of flying around an airport so we don't have total chaos, especially when we talk about untowered fields. For fixed wing people, a traffic pattern is typically flown at 1,000-foot AGL. Now, I say typically, there are some variations at some airports. They might have higher or lower depending on things like terrain, noise abatement, etc. And a default pattern is flown with left-hand turns. And again, that might be changed based on things like terrain. If there's a big mountain on one side of the airport, they might say, hey, if you're landing on this runway, it's going to be right traffic. And if you're landing on the opposite runway, it'll be left, for example. There's also some airports near me that have left traffic one way, right traffic the other way for noise abatement procedures. So when you have a default pattern for fixed wing, the turns are made to the left. That's because the pilot typically sits on the left side. And you have these different legs. So you take off and you're on the upwind or takeoff leg. You turn left 90 degrees onto the crosswind leg. Turn left again 90 degrees onto the downwind leg. Turn left again to the base leg, and then turn left again for final. Now, of course, as we discussed previously, if there is a wind, you need to adjust these turns so that you are flying a 90-degree pattern on the ground, but not necessarily turning 90 degrees each time, because you might have to turn more or less to adjust for the wind. So that is a fixed wing pattern. What about our helicopter patterns? Typically, a helicopter pattern is flown lower. We often will fly a 500-foot pattern, although I have seen airports where they flew a 1,000-foot pattern for noise abatement procedures, which I always thought was kind of interesting at one particular airport where the airport owner lived right by the airport and didn't like helicopter noise. But of course, multi-engine, radial-engined airplanes are fine. But little teeny tiny piston helicopters are apparently too noisy for some people. So the default pattern for a helicopter is going to be opposite. We fly a right pattern unless there's terrain, etc., or a local procedure that says we shouldn't. And we do the same thing. We take off on the upwind leg, turn right, crosswind, right, downwind, right, base, right, final. So that is a helicopter pattern. A couple other things about helicopter patterns. We typically fly them lower and possibly a little tighter. One of the things I like to do is I like to try to stay over an open area as much as I can, because I am flying pretty low. And if I were to have an engine failure, it would probably be better for me if I could land on something nice and open and flat instead of a bunch of trees. So let's go ahead and fly this in the sim. All right, here we are at the Mount Pocono Airport. It's a beautiful day to fly helicopters because the weather is kind of bad for all those fixed wing folks. So they are not flying today. It's pretty low clouds. Nearby, we've got quarter-mile visibility and snow and freezing fog, and that tends to keep them on the ground. So it's a perfect day to do a little pattern work. I am at the intersection with runway 23, which is what I'm going to use today. And this is pretty typically where I might take off in my helicopter if I come off of the ramp from high-tech helicopters. So let's go ahead and do it. So I'm going to start my hover taxi out toward the runway. I'm pulling in my power. using my pedals and such to adjust, pulling it up into a hover. I'm going to make my call. Pocono traffic, helicopter 496 is entering 23 for right close traffic, Mount Pocono. And I made that call before I crossed those lines that indicated the start of the runway. So I'm just going to come out here, make a nice gentle pedal turn. And I'll go right into my takeoff. So I'm going to start creeping forward. Going a little faster. Bringing up that speed, bringing up that speed. Bringing in some more power. Now one thing I'm going to do here is I'm going to turn and I'm going to somewhat fly down this other runway, which is runway 3113 here at Mount Pocono. And the reason that I'm doing this is, again, I want to stay over an open area. So this is my crosswind leg. I could go ahead and call it. Pocono traffic, helicopter 496, right crosswind 23 Mount Pocono. And I've got another 200 feet to climb here. And I'm going to go ahead and turn once again onto my downwind. Pocono traffic, helicopter 496 is the right downwind for 23 Mount Pocono. And I've got another 100 feet to climb. And what I'm trying to do here is, once again, I'm trying to go over an open area. I'm coming up on my traffic pattern altitude, 2,400 feet or 500 AGL. So I'm going to drop my collective a little bit and just level off here. And if you look just to my right, you'll see there's some warehouses. And I'm trying not to overfly those because that's kind of a bad idea. So I'm going to beam my touchdown point. I'm going to drop my collective just a little bit and let it start coming down. I normally want to be about 300 feet AGL on my final. So I want to lose 100 or 200 feet here, and between my downwind and my base, I want to lose 100 to 200 feet. So I'm going to turn my base, and once again, I'm not going to fly a perfect rectangle here. Instead, what I'm going to do is I'm going to fly over a road. You'll notice there's kind of a little parking lot to my left as well. But once again, I'm just trying to stay over an open area. I've gotten down to kind of my target altitude, around 2,200 here. It's just about time for me to turn final. Pocono traffic, helicopter 496, final 23 Mount Pocono. I'll come around. I'm making that zip line approach that we like to talk about. So now I'm coming in for my final approach, and we've learned how to do that before. So we'll go ahead and stop there. That's a traffic pattern in a helicopter. We'll see you next time.